So, things we know are that around here once is 360 degrees. And in our case, the polygon has 5 angles. So 360 divided by n, which is in our case 5, is equal to 72 degrees. So this angle right here is 72 degrees. But because right triangles are easier to work with to find the height and the length, we are going to be dividing it up into a right triangle in half. 72 degrees divided by 2 is equal to 36 degrees. To find the angle here is 90 minus 36 is 54 degrees, and we also know that the hypotenuse is 1. The area of a triangle is 1/2 base times height, so all we have to do now is find the base and the height. The sine equation is opposite times hypotenuse. We know that in our case, sine of 54 is equal to 1 opposite over 1. So the sine of 54 is equal to opposite, which means that this is our height. Next, we know that cosine is 1/2 adjacent over hypotenuse, and that the hypotenuse again is, so the cosine of 54, because the hypotenuse is 1, is adjacent over 1, which means cos of 54 equals A, which makes this our base. But this is half our base because we did an equation for this triangle. So we are going to have to double it. So base is actually equal to 2 cos 54. Okay. Now, 1/2 BH, so we are going to plug this in. So the area is equal to 1/2 sine 54 times 2 cos 54. The 2 and the 1/2 cancel each other out, so which leaves us with sine 54 times cosine of 54. This is the equation to find this one triangle that we have. But because we have 5 triangles, we are going to have to multiply it by 5 or by the number of sides of the polygon. So this is equal to n, number of sides, sine 54 cos 54. Now this 54 isn't going to stay the same, so we need to change the 54. The 54 is equal to 90 minus 180 divided by the number of sides. So our final equation for this is area equals n sine 90 minus 180 divided by n cos 90 minus 180 over n. You can see the equation for this circle with the polygon within it and the equation for the area of this circle with the polygon which is inside the polygon is very different. This is because in this case we know the radius is the hypotenuse, whereas in this case the radius is the height, and that is what changes what we know and that is why it differs whether we can use sine and cosine or tan. Drawing was the main problem-solving strategy that came in helpful as I was solving this problem. As you can see, I drew the circles with the polygons within them, and I could visualize the fact that the ratio between the circumference and the diameter was nearing pi, because I could see that the space in between the circle and the polygon was decreasing. In the case of this side, it was the exact same thing except with the circle in the polygon. And again, I could see the decreasing sides, and that was what showed me that the ratio between the circumference and the diameter was nearing pi.